All right, here we go. Answers to two of those related rate problems. Now, there are a lot of different ways that you can go about organizing your information, and I encourage you to find a way that works well for you. But I want to show you an example of a way that I think is very useful. Do you have to do this? No, not for sure, but I think it's going to be very helpful. I do recommend always drawing a picture. So here we've got Michael's climbing up a 13-foot ladder and Rachel's pulling out the bottom at some rate. So we want to draw ourselves a picture. Here's our ladder. It's leaning up against the wall. It's a pretty good looking ladder. Okay, and so here's our wall then that it's leaning up against, and there's the floor. And so I'm going to erase some of my extra segments here so you can kind of see the picture starting to form. So Michael's climbing up this ladder, and we want to label in our pictures things that we know. This right here, 13 feet long. What is happening? This here is going this way at 2 feet per second. What else? Well, that's about all that we know. Oh, no. No, how fast is the top of the ladder moving when the base is 5 feet away from the wall? So we know that we want this to be 5 feet away from the wall. So what other variables might be important here? We got to start to see a relationship between things. Now, what do we actually want? We want to know, I'm going to put that in a different color. We want to know this. How fast is that coming down here? So let's start to label some things. Let's call this hypotenuse here. Well, look at our picture. We've got three sides of a triangle here that we're interested with. And so hopefully it should be jumping out at you right now that the equation we want to be using in this problem is a squared plus b squared equals c squared. The equation, a squared plus b squared equals c squared. The equation that relates the three sides of the triangle. That's the equation we want to use. So let's over here make a chart of the values of our things for this problem. So A, let's make this side A, this side B, and this side C. So A, in this case, is going to be equal to 5. We care about this problem when A is 5. Now, what is dA dt? Every time we put a variable over here, we should also be putting its derivative over here. dA dt is the rate of change of A over time. dA dt is 2 feet per second. Now B, what is B? Well, I don't think we were given that in the problem, how high the ladder is up against the wall. What about dB dt? Well, this is the one we're trying to find, so I'm going to circle that because that's the one unknown we're trying to find here. Okay, now finally, what is C? C is the length of the ladder, that's 13 feet. Now dC dt. dC dt stands for how quickly is the length of the ladder changing over time. So think about it. How quickly is the length of that ladder changing over time? If you came up with 0, fantastic, because that ladder is not changing. Okay, so I'm going to do a little board dividing here. So here's my chart over here on the left. Here's my picture along with my equation that I'm going to use on the upper right. And now what we want to do is we want to take the we want to differentiate our equation. Remember, everything's a function of time now. So when we differentiate this equation, we're going to get 2a dA dt plus 2b dB dt equals 2c dC dt. Okay, I had to use chain rule with each of those variables because A is really A of t, B is really B of t, C is really C of t. Okay, so now I plug stuff in. I'm hoping that I can solve for dB dt. That's what I want to figure out. So I've got 2 times A was 5. dA dt is 2 plus 2. B I don't know, so I've got to leave B there. dB dt. dB dt equals 2 times C is 13 times 0. Okay, So let's do a little simplifying now. So 2 times 5 times 2, that's 20, plus 2b db dt equals 0. Now I'm trying to solve for dB dt. I have two variables still in this problem. I have both b and dB dt. This is why we went through all that work of taking all the geometric formulas, taking their derivatives, and saying how many variables are there, because we need to get to a situation where we have one variable in this problem. We do not yet. So we have to think, how can I get a value for this variable? Look right here. We have A, we have C. Is there any way we can use A and C to get a value for B? Yes, we can plug them right into here. We can plug them right into our Pythagorean theorem. If we know the length of the base is 5, and we know the length of the hypotenuse is 13, we can find the length of this other leg since this creates a right triangle. So let's go ahead and do this. I'm going to do this off on the side here. So we've got 5 squared plus b squared equals 13 squared. So that's 25 plus b squared equals 169. So that's b squared equals 144. So b equals 12. Now I can use that to finish the problem. 20 plus 2 times 12 dB dt equals 0. Okay, so I subtract my 20 and I divide by this 24 right here, and I'm going to get dB dt equals negative 20 over 24, which is negative 10 over 12, which is negative 5 over 6. Now finally, since this relates to something in the problem, I bet we can figure out what unit has to go with it. What unit describes how fast the top of this ladder is sliding down the wall? dB dt, how fast this is shrinking. Well, that's going to be feet per second. So negative 5.6 feet per second. All right, so that's that one. Let's move on to the next one. Okay, Lauren is filling a spherical balloon with helium. Okay, gonna draw myself a picture. Got my spherical balloon. The helium container has a flow rate of 1 cubic centimeter per second. I'm gonna leave myself some room to have air flowing into this balloon here. Air is coming in at 1 cubic centimeter per second. Okay, at what rate is the radius increasing when the radius is 10 centimeters? Radius is 10 centimeters. All right, so we have to organize our information here. Organize our information. We were given R equals 10 cm. And anytime I put a variable over here, I'm also going to put its derivative. dr dt equals, well, we don't know yet. Actually, at what rate is the radius increasing? At what rate is the radius increasing? That's exactly what we're trying to find. So I'm going to circle that. That's the one that I'm most interested in this problem. Okay, so what else do we have? We have 1 cubic centimeter per second. 1 cubic centimeter is going into that spherical balloon per second. So what does that tell us about the balloon? That tells us how fast the volume is changing. A cubic centimeter is a measure of volume, and 1 cubic centimeter per second means we're increasing the volume by 1 cubic centimeter per second. So dV dt equals 1. Okay, now do we know V? No, not yet. So what is the equation that we're probably going to be using here? What is the equation that relates these variables in our problem? Well, it's the volume equation. So real quickly here, we'll pull it up. Here we go. Volume equals 4/3 pi r cubed. Volume equals 4/3 pi r cubed. Okay. So there's our equation we want. Volume equals 4/3 pi r cubed. All right, I'm going to divide my board up again, kind of like last time. Okay, so every time in these problems, we're going to be taking the derivative of this equation we're interested in. So I take the derivative, dV dt equals, now 4/3 pi. 4/3 pi is just a constant multiple, so that goes along for the ride. 4/3 pi, and then r cubed, I have to do chain rule, so it becomes 3r squared dr dt. All right. So I hit enter here so I can have some more space. I'm going to do a little simplify. I've got a 4/3 and a multiplied by 3. Everything's being multiplied here, so I can simplify that. Those just make a 1. They cancel out, so I've got 4 pi r squared dr dt equals dv dt. Now I go ahead and plug in the information that I know from the problem. So what do I know? I know that I want to plug in 1 for dv dt. 1 equals 4 pi. Now, do I have an r? Yep, I have an r. 10 squared, and then times dr dt. Oh, look, we're down to one variable, and it's the variable we want to solve for. So from here, all we have to do is the math. All we have to do is isolate dr dt. So I go ahead and work out this nasty algebra on the right-hand side. 10 squared is 100. 100 times 4 is 400. 400 pi dr dt. And then I divide all of this stuff over. 1 over 400 pi dr. Oh, no, 1 over 400 pi equals dr dt. I got to figure out a good unit to go with this. So I look in my problem. Well, the radius is measured in centimeters. We're talking about things happening in seconds. So I'm guessing my change in my radius here is in centimeters per second. All right. Hopefully these two walkthroughs help you to continue on with those 6 problems. But I want you to focus on the 2 problems that I'm going to add at the bottom of this post. Please attempt those 2 problems for tomorrow. They will follow very similarly to these 2 that you just saw in this video. I want you to practice what you've learned, see if you can apply it to do the problems at the bottom of this post. All right, have a good rest of your evening.